Antarctica, the Sahara Desert. These are two desolate and unforgiving, pervasive environments found here on our planet. But for you and me, these locations will probably never have any impact on our lives. However, believe it or not, we all live in pervasive environments which are actually just as relentless as the intense heat of the Sahara or the ice-cold Antarctic. How could that be? Corrosion. No matter where we live, work, or play, we are all affected in some way by environmental degradation. The Department of Defense spends over $20 billion a year in a war combating the pervasive menace of corrosion. But did you know we have a strategic and tactical approach to countering this menace? An approach requiring various technologies focused on different equipment, weapon systems, and infrastructure. Specific protection and repair must be tailored to materials and environments in corrosion mitigation, thereby sustaining assets for coming generations. Otherwise, the world as we know it would be forever changed, and we could suddenly find ourselves living in a post-apocalyptic nightmare. Hi, I'm LeVar Burton. Come along with me today on an epic adventure as we look at corrosion comprehension, material sustainment on air, land, and sea. Decay, decomposition, deterioration, degeneration, oxidation, rust. All of these words are used in association with corrosion. In Title 10, United States Code Section 2228, and I quote, the term corrosion means the deterioration of a material or its properties due to a reaction of that material with its chemical environment. Now, most of us actually relate corrosion to rust. However, the atmosphere in which we breathe is the same chemical environment. So in reality, it affects everything: alloys, composites, polymers, ceramics. The invasiveness of corrosion goes way beyond rust to even include our own bodies. Our bodies contain a solution of over 70% sodium chloride at an average temperature of 98.6 degrees Fahrenheit. When a cell dies, it actually corroded. So what keeps us alive is also slowly killing us as we inevitably corrode. Such is life. Not to downplay the potential hazards of rust, it's one of the most pervasive forms of corrosion we have, and the one we are all most familiar with. Most of us have seen the vile red and brown areas on a vehicle, old bolts or nails, and even aging pipes exposed to the elements. Corrosion, it's really just a simple law of physical science. You see, when we manipulate the physical characteristics of a metal, it naturally wants to change back to its original state. So you can look at corrosion as a never-ending cycle. We pull the ore from the earth and process the raw material, altering its physical and chemical properties to form numerous useful everyday products. However, Mother Nature has other plans and continuously attempts to change the material back to its original state. If these materials are not treated to resist this cycle, they will deteriorate. They will corrode. Now, there are a few approaches to help materials resist Mother Nature's aggressive attacks. One of these is through the use of a paint made with polymers to provide exceptional adherence and protection. These are otherwise known as polymeric coatings. Polymers have been around for thousands of years and are found as either natural or synthetic materials. They're developed by linking together small molecules through covalent bonds. Now, polymers are utilized in many different ways. Polyethylene is used to make trash cans or even bulletproof vests, and polyvinyl chloride, or PVC, can be seen whenever you look under either your kitchen or bathroom sink. However, within the corrosion mitigation community, polymers used for coatings are the most critical. These include epoxides, alkyds, polyureas, phenolics, polyurethanes, acrylics, and polyesters. These types of coatings shield, protect and insulate the surface of materials from their environment and are in fact an exceptional corrosion mitigation technique. Besides using polymers, another way to combat corrosion is through the utilization of ceramics. Think about a toilet or commode and you have a decent idea as to what a ceramic is. In more scientific terms, ceramics are physically non-metallic and chemically inorganic. They have a reputation for being strong, stiff, chemically inert, but also very brittle. More importantly, they do not suffer from electrochemical corrosion. Now that's a tremendous check in the plus column when considering what materials to use when building systems. Unfortunately, ceramics are still susceptible to environmental degradation, and considering how many advanced engineering applications use ceramics in their construction, any degradation will lead to catastrophic results, the aftermath of which will be far greater than in any normal corrosive situation. Try dropping a toilet from a second-story window, and we instantly learn that ceramics have a propensity to shatter. Now, imagine if that occurred in a more important or intricate system, say on an aircraft flying at 30,000 feet. A corrosion engineer working in the lab would definitely call the toilet test a catastrophic failure of a system. And testing is tremendously important for accurate environmental sustainment. Since the DoD corrosion program began in January of 2003, great strides have been taken within the corrosion community relating to policies, processes, and procedures. One area where immense advancements have occurred is with corrosion testing. Now, we know and understand that corrosion occurs over time. It's a time-based phenomenon. In the past, seeing into the future of a material's lifespan seemed like just a pipe dream. But corrosion engineers have developed a way to do just that. Accelerated testing allows us to utilize time to our benefit. Accelerated testing places years of environmental impact on materials, making years seem like months and months seem like weeks. They are subjected to outdoor exposure tests in conjunction with accelerated laboratory testing in order to obtain substantial service life data. Because every climate presents distinct corrosion challenges, we utilize outdoor and laboratory testing sites all over the world. This way, we can gain a greater understanding of how new materials and coatings fare in real-world environmental situations. Some of these testing locations are the Navy Research Lab Corrosion Test Facility in Key West, Florida, the Tropical Regions Test Centers in Panama and Suriname, the Arctic Regions Test Center at Fort Greely, Alaska, U.S. Army Proving Grounds in Yuma, Arizona and Aberdeen, Maryland, and the Corrosion Technical Laboratory located at the Kennedy Space Center, Cape Canaveral, Florida. These are just a few of the many worldwide government testing sites that are used to assist in the war on corrosion and allow the Department of Defense to go to great lengths for improved material sustainment. Now that we've familiarized ourselves with a few corrosion prevention and control innovations, let's visit a couple of locations where the war on corrosion is happening right now. The first battlefront we're going to visit is Robins Air Force Base in Georgia. Here at Robins, we're going to get a closer look at their sustainment and mitigation practices on legacy aircraft systems. Now, as you can probably imagine, failures in the air are even more unforgiving than on the ground and can quickly become catastrophic. Ground-based units at least have the ability to predominantly use steel within their system's material integration. Aircraft must primarily use lightweight materials, such as aluminum, composites, or magnesium, to sustain their ability for flight. Unfortunately, all of these materials hold their own unique sustainment challenges. How about we turn our attention to corrosion mitigation and sustainment at Robins Air Force Base?
In 2009, the C5 maintenance program looked at MSG3, and that was a maintenance steering group based off of commercial industry practices. Prior to that, we were seeing a lot of corrosion work that was unexpected, over and above work, and that's really not a desirable thing when you're looking at money being spent on program depot maintenance. What MSG3 allowed us to do was to have better analysis, to have a better look, an in-depth look at what we're doing for corrosion, findings. What's typically what we see, I know some big things that we found with the C-5 is the biggest airplane in the DoD inventory. A lot of problems that we had with drain holes in the lower portion of the fuselage, and that's something as you know as we move forward in large aircraft design. I think that's something that it seems like such a minor thing, but it has caused some pretty major problems for us, particularly on the forward ramp.
The work they do at Robins on C-5s and C-130s is only a partial representation of their actual capabilities. The area we're looking at right now might seem like a location from some sort of popular science fiction film, but actually it's the control room for robotic aircraft stripping, where they handle paint stripping on smaller F-15 aircraft. Adjacent to the control room is the area where the actual work takes place. 3 robotic arms on the left, right, and center strip the paint off of an aircraft secured in the middle of the room. These robotic arms utilize a plastic media resembling sand to safely remove the paint from the aircraft. The robots work on a pre-designed program path which makes intricate work like stripping paint from a multi-million-dollar aircraft much simpler and quicker to accomplish. One of the bonuses to utilizing this process is that the media used for stripping the paint is reclaimed after each use and recycled, saving both money and the environment. Our thanks to the men and women waging a heartfelt battle against corrosion at Robins Air Force Base. Now, before we move on to our next corrosion battlefront location, we have the opportunity to listen in on a meeting with a handful of experienced corrosion mitigation experts. These men and women have been on the front lines of the corrosion battle every day for many years. They each have a unique story to tell describing where the corrosion battle has been and where the corrosion battle is most likely heading.
We have concerns now with what goes on with corrosion in jungles, because we've been fighting in the desert for essentially 2 generations as far as program managers go. So at least you 3 and anybody else can chime in. Tell us about some of the things you saw with the Vietnam era, the jungle, Southeast Asia, things that were unique corrosion. You know, you've got horror stories, all of you do, that people probably have forgotten today.
Back in '64, the Air Force decided they would build a mini corrosion program facility for the C-130 aircraft at Naha Air Base, Okinawa. That's where I was first assigned from. In '64, there's 30 of us young sergeants went over and was retrained in the corrosion, took over a contract facility working C-130A models. At that time, the upper wing planks were just completely destroyed by corrosion. I'm talking about you can take a screwdriver, for example, in certain areas and actually puncture holes completely through the upper surface of the wings. The outer wings were so bad in the outer wing fuel cell areas where the aileron attaches to the aircraft, we've actually punctured holes in that area. But when the pilots and co-pilots and the navigators and crew came to look at those airplanes, and they seen the severity of the corrosion on the aircraft, they were almost afraid to fly them back in. It was so bad that it's amazing how much corrosion was on the airplanes.
The issues you run into is it stays moist pretty much year-round. Some cases extremely wet year-round. If you're looking for a corrosion-prone area such as Guam, or where you have salt water, Kadena, where you have salt water and heat, you're looking at basically a salt fog chamber 24 hours a day, 7 days a week. We've seen a lot of improvements from the time that I came in '69 and progressed up the line, dealing with the corrosion inhibiting sealants, corrosion inhibiting primers, top coats that last a lot longer. So we've learned a lot of lessons. We've implemented a lot of the lessons learned. In some cases, we haven't done a real good job. In some cases, the environmental impact of the materials we're using are driving us to a different direction. So we expect to see probably increased corrosion if we don't integrate the new materials and processes in an effective manner.
We're going to revisit this engaging and informative meeting right after we head over to our second corrosion battlefront in Albany, Georgia. Here at the Marine Corps Logistics Base, they handle corrosion mitigation and repair operations on one of the largest depot lines in the country. Let's take a look at their heavy responsibility when it comes to battlefield equipment and systems.
Here at Production Plant Albany, we work on all types of ground vehicles. We don't do any aviation type work, but we've engineering equipment, tracked vehicles, as well as wheeled vehicles. The frequency of the vehicles that come through the depot really depends on the usage of the vehicle. There's a process within the Marine Corps that determines what's going to come through the depots and the priority of them. So we have an LAV that's come in. This will be for complete disassembly. So this is our immersion tank, zinc phosphate, aluminum conversion coat area. So you can see the process to the left is our zinc phosphate, the process to the right is our aluminum conversion coat. This item is a steel item that's had zinc applied, and what he's doing now is an average of the coating thickness is to make sure that we have it properly applied and in the proper amount. What we do in the component area as far as the QA process is 5 components per shift will be randomly selected to make sure each step of the process is as it's supposed to be. This area, the plate has been removed. An intermediate step in the paint process, and you can see this masked off area has been zinc primed, epoxy primed, and what they're going to do in the welding shop is now they're going to weld another plate over this, and then they'll stitch weld it, they'll seal those seams as you saw on the line, and then the whole vehicle will be zinc primed and epoxy primed over. But the big thing here is that we have a coating underneath that plate, so we're not going to have that problem with surface cracking potential.
The mitigation and sustainment processes they go through at the Marine Corps Logistics Base is imperative to continue serving our nation's warriors. A special thanks to everyone in Albany, Georgia, who helped make our visit so engaging. But now, let's head back behind closed doors with a few of our nation's corrosion control subject matter experts as they discuss mitigation situations they've been involved with in the past versus what they're doing now to deter environmental degradation.
So Larry Clark, tell us, you were at Charleston, and that's a pretty severe environment. It's hot, it's wet. What's the difference between that and what you saw at Guam and Okinawa and Vietnam? What's the difference?
When you go to the Far East, in Vietnam, I was 2 years over there, 3 years in Kadena, made several visits to Guam. The overall temperature, the heat of the year, and the overall humidity year-round, along with high rain, and then if you introduce a coastal environment with it, you got corrosion problems. You got corrosion problems that you just don't see in normal circumstances in a conus basing environment. Very few conus basings have the kind of problems that you see out there, unless you get down to Key West, places like that.
Okay, let me switch to another subject dear to everybody's heart, I'm sure. Kayla, tell us about DeLorean, the slump and Longeron, and how much of a problem that is these days and what you're doing about it.
We've seen a lot of these issues, not just on the USF aircraft, but as on the Coast Guard aircraft, we see a lot of the same issues, and we're just trying to figure out the best products to implement on those areas and the easiest ones, because we don't always have the best access or method or equipment here to implement the products, so we're just trying to do that as best we can.
Changing materials or just the same old alloys and so forth?
Mostly the same alloys. Cost is certainly a factor on anytime you want to switch materials in an area. You have to evaluate the cost and figure out whether it's beneficial to do that or just replace with the same material, replace the part when it does corrode.
So Larry Cornwell, you're on a Coast Guard cutter with, so you're in the salt spray with 130s and helicopters, and probably some in cooler environments like Alaska, but tell us about what you saw, what was happening with Coast Guard airplanes relative to, say, Air Force airplanes.
I think one of the big differences between the two services is the operating environment. In terms of whenever you're operating over water, typically the Air Force birds operate at a higher altitude, and the Coast Guard aircraft, by and large, operate at a regime somewhere under 1,000 feet. Oftentimes it's 300 to 500 feet over salt water, and so that was pretty much the normal operating environment on a 130. And so you're constantly being exposed to the corrosion as a result of the salt spray and everything like that. So the helicopters, of course, were even worse because we did have helicopters that would either land in the water and or off of cutters and so forth and do rescues and that type of thing, so they'd be bathed in the salt water. So those platforms will get salt water and it just saturated on the interior. So corrosion in interior components of the helicopters was extremely severe, and on the 130s, for example, not so severe on the interior, but a lot of external issues with flight controls in particular, and flaps. Flaps are always a big problem, and of course that's kind of universal, but it was really more so in the Coast Guard.
You don't get to capture the experiences of prominent veterans sharing their mitigation and sustainment know-how going all the way back to the Vietnam War every day. Nor do we often get to go behind the scenes of one of the most critical bases supporting the operational readiness of the U.S. Atlantic Fleet. This is Joint Expeditionary Base Little Creek, Fort Story, where some of the mighty ships of the U.S. Navy are maintained and readied to immediately respond to wartime and peacetime missions around the globe. The USS Oak Hill is a Harper's Ferry-class dock landing ship and was commissioned on June 8, 1996. Since her commission, she has seen a number of important and historic missions, from recovering wreckage of TWA Flight 800, operating as a support ship during Operation Enduring Freedom in 2002, and had the same mission in 2006 in support of the global war on terrorism. With her active duty schedule, the Oak Hill has gone through numerous corrosion mitigation and sustainment processes.
The kind of corrosion problems that we see are mostly to do with salt water. Since we have to fill up half the ship with salt water, the whole back aft of the ship is basically submerged in water, so we see a lot of corrosion around there. Also, just everywhere, really. While the ship is underway, we get a lot of splash up on deck. Most of the corrosion repairs that we do is more of the, after we cut the metal, we have to paint it, make sure it looks good. My job is to make sure that it doesn't look like it was repaired at all.
The stern gate of the USS Oak Hill is where they launch amphibious craft from the ship by ballasting down the well deck and lowering the stern gate to the sea. You can immediately see why this part of the ship is one of the main trouble spots for corrosion due to its direct contact with salt spray and the sea itself. For corrosion sustainment, the gate must be lowered and then the old paint must be sanded or, in some instances, chipped away. This is followed by applying a coating system to the metal, a primer, and top coat to the gate. The stern gate controller, which lowers and raises the gate, experienced major corrosion issues on this type of craft due to salt spray exposure on the brass electrical box enclosures. The resulting corrosion damage would not remain within the enclosure, as it would continue to spread, breaching the paint underneath the box and ultimately begin to affect the steel of the ship wall. From these occurrences, a mitigation technique was developed. The Navy switched to a use of composite box to replace the brass, an improvement to the paint on the steel wall underneath the electrical box, and an air gap between the box and the paint on the wall. The result was a substantial decrease in corrosions affecting this system. The Harper's Ferry-class dock landing ships, like the USS Oak Hill, have been undergoing major midlife upgrades since 2009, which included extensive corrosion mitigation and sustainment. The Navy plans on keeping these amphibious transport dock-type ships in service through 2038. The Department of Defense already faces a gargantuan corrosion mitigation and sustainment challenge with weapon systems and equipment. But consider this. With a property portfolio of more than 555,000 facilities across more than 5,000 sites worldwide and covering more than 28 million acres, all of which are located in a broad range of environmental severity zones, that challenge becomes even more daunting. Facilities located in coastal environments tend to have a high ESI, or Environmental Severity Index rating. This rating is determined by placing a standard package of materials out in operational environments for a specific amount of time. They are then brought to a lab where the films are detached from the coupons and a weight loss is calculated, expressing the amount of material removed by corrosion. Within each separate environment, with various ESI ratings, there are different corrosion prevention control requirements. For instance, in a coastal environment, the use of high-quality concrete, which is impervious to water and chloride intrusion, would help mitigate corrosion on the reinforcing steel. Instead of carbon steel, galvanized steel, stainless steel, and non-metallic components would be used. Wherever stainless and galvanized steel is not used, coatings would be applied to provide a barrier against the environment. These materials might not be the best solution in other environments with different ESIs. Without proper corrosion mitigation and sustainment processes, there would be a multitude of failures which could cost many lives. It's so important when you're dealing with infrastructure to build your structures to coincide with its environment. For example, when doing so with, say, a roof in the tropics, like this one, you want to use wood or aluminum or coated galvanized steel. As you can see, the design provides an open canopy giving you lots of flowing air. Doing this deters corrosion from forming, and even if it does, it will take a long time to develop. The types of fasteners utilized for the aluminum roof are galvanized screws and rubber gaskets. Sure, it's not going to last forever, but it will last for a very long time. The key is not to close off areas, as that will only attract rodents, but it will also trap moisture. This is just a snapshot of how infrastructure can be built for long-term sustainment. Building in the location while cooperating with the environment. Today, we visited a few of the major battlefronts within the war being waged on corrosion. At each location, we saw how they utilized superior weapons developed by scientists and engineers to prevent, detect, predict, and manage the pervasive menace which is corrosion. We owe all the men and women fighting daily on the front lines against corrosion a sizable debt of gratitude, just as we do every warrior and support person in our nation's active military and reserves. I'm LeVar Burton, and I'd like to thank you for joining me today on this journey of discovery deep within the trenches of the corrosion war, and remind you that rust never sleeps.
Our material town, it comes in pits, it comes in cracks, it's all over your railroad tracks. You'll see it everywhere you look. Here comes the rusty hook. The pervasive menace never sleeps.